In recent years, among new energy vehicle companies, the most frequently mentioned term is undoubtedly 800 volts.
This year, we have successfully achieved the maiden flight of a town-class prototype equipped with CATL condensed battery.
Because CATL has just declared war on the entire battery industry with its game-changing condensed battery.
There have been numerous efforts to advance battery technology, with lithium-ion seeing impressive improvements over the years,
effectively rendering Toyota's long-hyped solid-state ambitions obsolete. Dubbed the ultimate energy revolution, CATL's innovative approach not only bypasses common pitfalls of solid-state tech, but doubles capacity through a remarkable 3D honeycomb anode. The result? Electric vehicles with far greater range, lightning-fast charging, and safer performance. Forget everything you thought you knew about batteries, because CATL's futuristic breakthrough has arrived. CATL's revolutionary approach to batteries. CATL has just shattered every limit in battery technology, leaving solid-state dreams in the dust and promising an electrifying future. Their condensed battery, a radical new design, doesn't merely tweak old systems, it reinvents them. By going beyond Toyota's well-known solid-state goals,
my inspiration of the car is elegant yet dynamic because of that beautiful car that every engineer inspired.
CATL ensures higher energy density, faster charging, and improved safety that outclasses almost everything on the market. It's a massive leap toward revolutionizing electric vehicles, phones, and even power grids. And best of all, it's poised to do so at a surprisingly low cost. The magic starts with a 3D honeycomb anode, which doubles the capacity of standard designs. By creating tiny channels only 20 nanometers wide, lithium ions can move freely without causing damaging stress. That means less wear, longer overall life, and a jump in how much energy each cell can store. Next comes CATL's biomimetic electrolyte interface, a self-assembling layer that prevents dangerous dendrites from growing. This super-strong barrier cranks up conductivity, allowing the use of powerful lithium metal anodes.
Lithium-ion batteries are in our phones, in our cars, and they even won the Nobel Prize in Chemistry this year. They've revolutionized the way we power our gadgets.
It's like a fortress protecting the battery from shorts, fires, and performance drops. Bumping energy density to around 350 Wh/kg, these batteries blow past typical lithium-ion limits and can extend electric vehicle range to over 600 miles. Faster charging is part of the package too, with rates hitting up to 5C. CATL's design addresses that through stable chemistry and robust structures. They claim up to 5,000 cycles, 5 times the durability of older batteries. What's truly wild is the potential to slash costs to $80 per kWh, making these power packs cheaper and more accessible than ever. This breakthrough changes more than cars. Picture entire power grids stabilized by these high-capacity cells, storing renewable energy for round-the-clock supply. Think about aviation, where battery weight has been a major barrier. With CATL's condensed batteries, electric flights become a more realistic option. Even smartphones and wearables can benefit, promising more power in slimmer, safer forms. Sure, roadblocks remain, like large-scale production challenges and ensuring total safety. But if CATL keeps climbing, the entire energy landscape might never look the same again. Ultimately, CATL's move to sidestep solid-state limits is one of the biggest twists in battery history. By marrying a honeycomb anode with a nature-inspired interface, they've catapulted performance, safety, and affordability into new territory. Toyota and other contenders may scramble to keep up, but the future looks bright for CATL. As these condensed batteries inch closer to mass adoption, expect an electric revolution that jolts every corner of life. 3D honeycomb anode. Prepare for the biggest battery revolution since the dawn of electricity. CATL's 3D honeycomb anode is shaking the entire industry, leaving old designs in the dust. Instead of using a flat, cramped layout, this game-changing approach is shaped like a beehive, creating countless tiny channels that allow lithium ions to move faster and store more energy. Each channel is only 20 nanometers wide, so small you could fit thousands of them across a human hair. This honeycomb pattern not only doubles the anode's capacity to 400 mAh, but also reduces stress during charging, preventing long-term damage. Think of it as a spacious honeycomb for your battery, offering more room for every single ion. Imagine cruising hundreds of extra miles in your electric vehicle without worrying about finding a charger. Or picture quick charging times that fit into your coffee break. That's the crazy potential behind this intricate honeycomb design. By letting lithium ions flow in and out like busy bees,
a technology that can produce lithium-ion microbatteries with 3D printers,
the new anode design avoids those dreaded battery slowdowns and early deaths. The result is a longer-lasting, more powerful battery that can drive you farther than ever before. Best of all, this approach isn't just for electric cars. From laptops that stay alive for hours to renewable energy storage that keeps the lights on all night, the applications are boundless. It's what happens when engineers stop tinkering with the same old tweaks and create an entirely new framework. The 3D honeycomb anode rethinks the fundamental structure of storing energy, and consumers everywhere stand to benefit. Of course, this breakthrough wasn't easy. Researchers had to solve tricky problems like dendrite growth and capacity fade. But by crafting a stable, bio-inspired interface alongside the honeycomb design, CATL conquered these challenges. The battery remains safer, more robust, and ready for high-speed charging cycles that would kill a typical lithium-ion cell. Yes, this is a giant leap forward for the future of clean transportation and portable electronics. The 3D honeycomb anode is a prime example of how thinking outside the box can yield incredible results. So wave goodbye to dated battery worries and say hello to a sleek, powerful new era. Your devices will run longer, your car will drive farther, and guess what? We're only at the beginning of this honeycomb revolution. Expect more mind-blowing breakthroughs as CATL refines this design, pushing battery tech well beyond what we thought was possible. The future looks brighter, faster, and more sustainable than ever. Biomimetic electrolyte interface. CATL's biomimetic electrolyte interface has turned the battery world upside down by solving one of the biggest roadblocks to adopting advanced lithium metal anodes. Derived from nature's own designs, this interface forms a tough, self-assembling barrier that keeps destructive dendrites in check. These spiky growths can puncture batteries and cause dangerous short circuits, but biomimicry has given CATL a new tool to suppress them. By studying how living cells protect themselves,
the chairman of the Chinese battery giant, CATL, also told Bloomberg that the company is on track.
CATL engineers created an interface that ensures stable cycling, high conductivity, and impressive safety. Most importantly, it finally does away with the need for solid electrolytes, which have proven difficult and costly to produce. Instead, the biomimetic interface works with a gel-based electrolyte, boosting conductivity by 100,000 times compared to rigid solid-state setups. Thanks to this approach, lithium metal can be used in the anode, storing double the energy of standard graphite cells. Paired with the three-dimensional honeycomb anode design, the biomimetic interface opens the door to electric vehicles driving farther, charging faster, and lasting longer. It also slashes risks by neutralizing the biggest cause of fires in next-generation batteries. In simpler terms, think of this interface like a sturdy cell membrane that only lets the right ions pass, while blocking harmful expansions. This gives CATL's condensed battery the best features of solid-state technology, safety, and high density, without the usual trade-offs or sky-high costs. In fact, CATL aims to cut battery production expenses to about $80 per kilowatt-hour, putting it on track to compete with traditional lithium-ion packs. Beyond consumer EVs, the biomimetic electrolyte interface can transform renewable energy storage, powering communities through day and night without fear of massive battery failures. It could also make electric aviation more viable, providing potent energy-to-weight ratios and a safer platform for the skies. With such wide-ranging potential, CATL's breakthrough has earned global attention. Still, challenges remain. Mass manufacturing of these advanced batteries requires care and capital, and scaling up from lab tests to full production can reveal new hurdles. CATL, however, seems confident, pushing towards small series production by 2027 and building partnerships to accelerate growth. In the end, the biomimetic electrolyte interface may finally peel away the last hurdles to high-performance lithium metal batteries. By coaxing nature's wisdom into every cell, CATL is proving that sometimes the best way to solve modern problems is to follow life's oldest tricks. Expect these biomimetic barriers to spread across many industries, revolutionizing how we power cars, planes, and entire communities. The full potential of CATL's condensed battery awaits. Higher energy density. One of the most exciting parts of CATL's condensed battery is its significantly higher energy density. Traditional lithium-ion batteries often hover around 250 Wh/kg, which limits how far an electric vehicle can drive on a single charge. By contrast, CATL's advanced cathode and overall design push this figure to around 350 Wh/kg, marking a substantial 40% increase. In practical terms, this difference could let you drive up to 620 miles on one charge, eliminating the anxiety of finding a charger during long trips. The secret lies in combining a 3D honeycomb anode with a clever, nature-inspired electrolyte interface. By increasing how many lithium ions can fit inside the anode, CATL effectively raises the total energy stored. This honeycomb structure offers tiny channels just 20 nanometers wide for ions to travel, doubling the capacity when compared to usual battery designs. Meanwhile, the biomimetic electrolyte interface prevents harmful dendrites from growing, which can cause short circuits and reduce performance.
One of today's biggest issue in lithium-ion battery, which is short-circuiting of cells after a few cycles of operation. So the origin for short-circuiting is the formation of so-called lithium dendrites.
Because of these breakthroughs, the battery can achieve rapid charging speeds without sacrificing safety. Higher energy density doesn't just mean improved range for electric cars. It also paves the way for better energy storage solutions in solar and wind systems. By packing more energy into each cell, these batteries can capture and release renewable power more efficiently. That means less waste, lower costs, and a more reliable grid for communities that depend on clean energy. Electric aviation is another prime candidate for this robust energy density boost. Aircraft demand large amounts of power to take off and stay airborne. With heavier batteries, flight times shrink and costs rise. But if a battery stores more energy for the same weight, electric planes can soar farther, bringing down emissions in a sector long reliant on fossil fuels. Despite these bright possibilities, challenges still exist. Higher energy density demands robust materials, precise engineering, and careful temperature control to ensure reliability over the battery's life. CATL is meeting these hurdles head-on with plans for small series production by 2027 and ongoing research into safely scaling up. At the same time, they aim to bring costs down to around $80 per kWh, making these next-generation batteries competitive with traditional lithium-ion packs. By boosting energy density, CATL's condensed battery technology might just define the future of power. If they succeed, long road trips in electric cars, more stable renewable energy grids, and possibly even electric commercial flights could become part of our everyday reality. This is the promise of a brighter, cleaner, and truly electrifying tomorrow. Wide applications. CATL's condensed battery technology offers a wide range of applications that could change many industries. By focusing on a new 3D honeycomb anode and a biomimetic electrolyte interface, CATL has bypassed many of the problems that come with older lithium-ion or solid-state batteries. This improved design means higher energy density, quicker charging, and better safety compared to what is on the market now. One main area where these batteries can excel is electric vehicles. With ranges surpassing 600 miles on a single charge, drivers can worry less about where to find a charger. Plus, faster charging rates allow EV owners to spend shorter times at charging stations. As a result, more people may feel confident switching from gasoline-powered cars to electric models, helping reduce carbon emissions worldwide. But the potential goes far beyond just cars. Think about renewable energy storage for communities that rely on solar or wind power. Batteries from CATL can store more energy in a smaller space, providing a reliable backup when the sun goes down or the wind stops blowing. This could help remote areas that rely on fossil fuels switch to cleaner, more efficient power sources. In addition, The high energy density and improved safety characteristics make CATL's technology promising for electric aviation. Lightweight, powerful batteries could enable longer distance flights with fewer emissions, helping to cut down on one of the most polluting sectors in transportation. Even consumer electronics, like smartphones and laptops, stand to benefit from smaller, longer-lasting power cells. Industries that depend on stable power supplies, such as data centers and hospitals, could also take advantage of these next-generation batteries. Being able to rely on a robust, high-capacity storage system during outages ensures mission-critical services remain up and running. The result is fewer disruptions, more efficient energy usage, and cost savings over time. Still, commercializing this breakthrough will take effort. Challenges associated with mass production and scaling must be resolved before these benefits can be widely achieved. Yet CATL's progress is significant, signifying the dawn of a new battery era. From cleaner roads to stable microgrids and even electric planes, the possibilities for this condensed battery are truly vast. As CATL continues refining its design and exploring partnerships, we may soon see large-scale adoption in many industries. This technology may spark a revolution in how we store and use energy, building a greener, more sustainable world for everyone. Challenges and cost goals. The path to bringing CATL's condensed battery to market is not easy. Their groundbreaking design, featuring a 3D honeycomb anode and a biomimetic electrolyte interface, faces serious hurdles in production, cost, and performance. Overcoming these challenges is vital if they want to reshape the battery landscape and meet future energy demands. One key obstacle is scaling up manufacturing to meet global demand while keeping the technology stable and safe. CATL aims to address this by refining production processes and building strategic partnerships to roll out small series models by 2027. They are also pushing for advanced quality checks that ensure each battery cell meets strict performance standards, even in extreme climates. Another challenge is to optimize charging speeds and to keep the battery reliable during thousands of cycles. CATL's solution involves fine-tuning their biomimetic interface, boosting conductivity, and reducing dendrite formation so the battery retains capacity for up to 5,000 cycles.
As a battery charges, lithium ions can deposit irregularly on the anode, forming spiky structures called dendrites.
Cost remains the most pressing concern. Traditional lithium-ion packs hover around $100 per kilowatt-hour, while some solid-state versions exceed that by a wide margin. CATL, however, targets a breakthrough $80 per kilowatt-hour, lowering costs by 20% and making their technology more competitive. Achieving this goal demands ramped-up production methods, improved supply chains for raw materials, and economies of scale that come with high-volume manufacturing. Developing cutting-edge recycling techniques is also essential, since reclaiming valuable metals can further reduce expenses and environmental impact. CATL's engineers must prove reliability in real-world conditions, from scorching deserts to frozen landscapes, ensuring consistent performance at minimal cost. Only then can they justify large-scale investments in new factories and manufacturing lines, bringing these condensed batteries to mainstream markets. Though the road is long, the prize is massive. An affordable, long-lasting battery that can power electric vehicles, store renewable energy, and spark revolutions in aviation. With market projections hitting $135 billion by 2027, CATL's condensed cells could reshape the competitive landscape if they deliver on their cost targets. Continued improvements in materials, scaling methods, and production efficiencies will determine whether this technology truly replaces traditional lithium-ion as a global standard. Every step forward makes electric transport and green energy more appealing, sparking hope for a cleaner, cost-effective future. If CATL succeeds, drivers will enjoy faster charges, longer range, and reasonable prices, key reasons to finally ditch the gas pump for good. The company's plan to hit $80 per kilowatt-hour signals confidence that these challenges are solvable, making condensed batteries a reality sooner rather than later.
Welcome back. Over the past 2 years, the number of Chinese auto exports jumped by more than half. Elizabeth Palmer shows us how more Americans could soon get the chance to drive a vehicle made in China.
These vehicles, equipped with cutting-edge driver assistance systems and electric powertrains, represent the pinnacle of modern automotive design. They are not just about technological advancements, they represent the future of transportation and have left the world in awe. Which Chinese cars are leading the charge in technological innovation, and how are they pushing the limits of the automotive revolution? Join us as we reveal advanced Chinese next-generation transport that shocks everyone. NIO ET9 Sedan. NIO is one of the leading Chinese electric vehicle manufacturers, and it recently unveiled its flagship model, the ET9. This model brings the company's lineup to 9 electric vehicles. While NIO intends to enter the US market, it focuses on its current domestic demand.
According to China EV Post, NIO plans to sell its first car in the US by 2025. The company will import its China-built electric vehicles into the US, rather than manufacturing them locally.
The ET9 boasts impressive technology, featuring a 900-volt electrical architecture and steer-by-wire technology. Here is a big fact. In terms of size, the ET9 surpasses even the extended wheelbase version of the Bentley Bentayga, measuring 209.7 inches in length compared to the Bentayga's 208.9 inches. NIO has coined the term land jet to describe the ET9. It features a powerful all-wheel drive system with 2 electric motors. A smaller 241 horsepower asynchronous motor powers the front wheels, while a larger 456 horsepower permanent magnet synchronous motor drives the rear wheels, resulting in a combined output of 697 horsepower. The ET9 is equipped with a 120.0 kilowatt-hour battery that operates at a high voltage of 925 volts and is capable of fast DC charging at speeds of up to 600 kilowatts. Although specific performance figures and range estimates are not yet available, NIO claims that under ideal conditions, the ET9 can recharge at a rate that provides up to 158 miles of additional range in just 5 minutes. NIO offers automated battery swap stations in China to enhance convenience further, replacing depleted batteries with fully charged ones in under 5 minutes.
The idea of swapping batteries on electric vehicles isn't exactly new. The technology is already available and growing fast in China.
The ET9 is the first NIO model to incorporate steer-by-wire technology, a feature expected to become more prevalent in the automotive industry. Like the Tesla Cybertruck, the ET9 eliminates the traditional mechanical connection between the steering wheel and the steering rack, relying solely on electrical signals for input and feedback. This technology helps redundancy in case of power failure, ensuring the driver's and passengers' safety. NIO has previously collaborated with ZF Group on steer-by-wire technology, suggesting that this supplier developed the ET9 system. Additionally, the ET9 features rear-wheel steering and an active suspension with height-adjustable air springs, further enhancing its driving dynamics. The ET9, like many other luxury Chinese vehicles, prioritizes the comfort and convenience of rear-seat passengers. Inspired by private jets, the rear seats offer a luxurious experience with reclining capabilities, an aircraft-style tray table, and motorized shades for privacy and noise reduction. That is not all. The ET9 has multiple digital displays, including a 15.6-inch central touchscreen, 14.6-inch displays for rear passengers, and a smaller 8.0-inch control screen in the rear. In terms of advanced driving technology, the ET9 supports higher-level assisted driving features.
Notably, the vehicle introduces a self-driving chip developed in-house, making it the pioneer in employing the advanced 5-nanometer process technology within China's automotive sector.
Thanks to its 3 LiDAR arrays. The Shenji NX 9031 provides the powerful computing capabilities required for these systems and is claimed to be the world's first 5-nanometer automotive-grade chip. This impressive technology can undoubtedly be a conversation starter for ET9 owners. The ET9 is currently available for pre-orders in China, with deliveries expected to begin in the first quarter of 2025. Prices start at approximately $112,000 at current exchange rates. Would you love to have one if the company eventually exports this model to the United States? Tell us in the comment section. Moving on to the next marvel of modern Chinese transportation, A train that doesn't roll along tracks. This will leave you shocked. Suspended maglev train. Have you ever heard of the world's fastest trains? Many of these high-speed trains originate in Asia. Interestingly, some trains travel above the ground, suspended beneath the track. China's latest high-speed train relies on magnetic levitation technology to travel through tubes up to 4,000 kilometers per hour. In recent tests, the maglev train reached 623 kilometers per hour, surpassing the fastest currently operational trains. While not yet in commercial service, the train achieved a new speed record of 623 kilometers per hour during a test of its low-vacuum tube technology in February.
In Chengdu, engineers are working on the future of rail travel, the maglev. Theoretically, it could travel at a flying speed of over 500 kilometers per hour. That is the dream. In practice, things are more complicated.
This marks a significant milestone for the project, as the train traveled stably through a 2-kilometer-long tube. The Aerospace Science and Industry Corporation has not disclosed the exact speed achieved in this test, but confirmed that it was faster than the previous record. Maglev trains utilize magnetic levitation technology, employing magnets' repulsive and attractive forces to guide, accelerate, and decelerate the train. This eliminates the need for wheels, brakes, and other heavy components, making maglev trains significantly lighter. This train can rival even the speed of commercial airplanes. The benefits of maglev trains will leave you speechless. Commuters can travel from greater distances to cities, and the increased logistics speed will positively impact businesses. With the potential to reach more than 1,000 kilometers per hour, maglev trains can compete with airplanes, offering a viable alternative for long-distance travel. Associate Professor Jonathan Kuldrick from the ANU College of Engineering, Computing, and Cybernetics states that a high-speed train like China's maglev would significantly help large countries. For instance, commuting 400 kilometers in approximately half an hour is like nothing we've ever seen. This would enable people to live in areas outside of major cities. Mr. Kuldrick believes that these fast trains could also be environmentally beneficial. He estimates that completely replacing regional passenger aircraft with ultra-high-speed trains in certain countries could reduce carbon emissions by 3 to 4%. Designers are pushing the boundaries of train technology. Mao Kai, the technical chief of the project, mentioned that the train surpasses the record of 3,529.6 kilometers per hour set by the SR-71 Blackbird reconnaissance aircraft, the fastest human-crewed aircraft in history.
The SR-71, nicknamed Blackbird and Habu, based off the designs of the A-12 and YF-A-12, was first seen soaring in the skies in 1964.
Japan's fastest bullet train can only reach a maximum speed of approximately 320 kilometers per hour. However, Japan also has a 42-kilometer test track, where a maglev train has achieved a speed of 503 kilometers per hour. Dr. Laird said this maglev train will not enter service until at least 2030. When Japan's new generation of maglev trains becomes operational, they are expected to travel at a maximum speed of 500 kilometers per hour between Tokyo and Nagoya. The following vehicle on our list is a two-wheeler with astonishing capabilities. Hoverboard, Shane. This is the latest tool from Shane Chen, the creator of the original hoverboard. Shane is the first two-wheeled EV concept that is ready for everyday use. Chen, the inventor of the self-balancing hovertrack scooter, also known as the hoverboard, patented his creation in 2012. Chen holds 76 patents in the United States despite widespread copying by other Chinese manufacturers. Chen describes Shane as a groundbreaking moment in automotive history, marking the practicality of a parallel two-wheeled electric car. While the vehicle's exterior may resemble a toy, Shane is designed to accommodate 5 adults comfortably. The interior evokes the sensation of preparing for a futuristic roller coaster ride. When in motion, the vehicle's wheels automatically adjust to maintain balance. The creator believes that this design enables safe travel at high speeds. Shane, quote, S shifting center of gravity counteracts driving and braking forces.
Created by the inventor of the hoverboard, Shane combines several fascinating technologies. If you like big wheels, you'll love Shane, a new electric vehicle concept with 60-inch rims.
Ensuring stability comparable to a four-wheeled vehicle. The two-wheel differential speed control simplifies parking and maneuvering. The vehicle's large wheels minimize rolling resistance and incorporate regenerative shocks to convert damping energy into battery power. Although not mentioned, Shane's roof appears to feature solar panel technology. Chen expresses confidence in Shane's potential to revolutionize mobility and seeks partners to bring the concept to fruition. The interior lacks a traditional steering wheel. Let us know your thoughts in the comment section below. If you enjoyed the video, make sure you like, share, and subscribe. Also, click the next video shown on your screen. You will enjoy it.